Let me quickly introduce myself. I'm a senior consultant with IC Consult GmbH, located in Germany. I've been working with the company for about 5.5 years now, working exclusively with SailPoint IdentityIQ, which coincidentally also goes for my colleague Christopher, who is going to assist me in the presentation, or rather take over during the course of the presentation. Before I begin, just a quick shout out to Jordan and his team. Great work so far, very interesting talks, so kudos for putting all that together. With that being said, let me just go over the agenda for our presentation really quickly. As you can guess, as you might have guessed by the title and the agenda you're seeing, today's topic is going to be logging. But in order to give you a little bit of context why we did what we did, I'm going to start with a little challenge, meaning showing what we actually did and what we faced and why we did what we did. I'm then going to show you how we approached that problem and what we actually implemented in order to help us a little bit. And after that, we're going to do a little show and tell in form of a demonstration by Christopher. In general, what we're presenting today is just pretty much a quality of life features for ourselves, meaning a developer and maybe a support engineer who has to debug these kind of problems for us. Let's start at the beginning with an error that we face. I mean, we all know that SailPoint tends to present us with, let's say, unspecific error messages more often than not. And in generally, not only with SailPoint, but with all products, analyzing errors is really a pain. It's difficult to do. Especially when it comes to Bean shell code, which tends to present even less specific error messages than when you implement something in Java, and especially when it comes to errors that happen in a productive environment, because normally those kind of errors that happen in production are less the kind of your typical syntax error or something like that. That should be weeded out before it even goes there. But typically, those errors are more data-driven, meaning a value is not set in the way you expect it to be, or it isn't there in the first place. So if you're not very careful, and sometimes a corner case just escapes you during testing and during development, you will see errors like the ones you see on the page below at the bottom, like your good old null pointer, which specifically tends to be very unspecific, if you can say it like that. Typically, even the stack trace doesn't give you much information on where to go on. And assuming that you are able to reproduce an error, that's where we came from. Our first thought was when we thought about how can we alleviate the problem of finding out where the error is exactly in our code without being able to just change the code itself. The obvious solution that came to our mind was just using log statements. I think yesterday we had a talk about, by Adam, if I remember correctly, that briefly mentioned best practices for logging. So that might have, if you've seen that talk, you might have already got from that using logging seems pretty easy. It seems pretty straightforward, but I would argue that it isn't, especially when you want to include logging messages beforehand in your code that will actually help you in the event of an error. Because when you want to do that beforehand, you always have to think about different things that you want to display. You have to ask yourself, what is the right level to display which information at, meaning which log level. Do you want to display something at a trace level, or only at a trace level, or on a debug level, or is it maybe a warning level? So you have to think about that. And normally you would like to write different log messages on different log levels. So doing all that by hand can get pretty tedious and quite a lot, frankly, and essentially bloat up your code by a lot. And it's really a hassle, even to review. I mean, how often we often have the problem that just the code review just got back with the message, please add more log messages, or you forgot your log messages. So that's just, it's just annoying to do and worry about that. And it really only helps if you do it everywhere in your code, because I bet you that if you don't do it in a method or a class, this will be the one that throws an error. That's just Murphy's Law, really. It always happens where you don't expect it. So using logging isn't as easy as it seems. So our solution for that was, we approached it as a developer. So how can we automate things? How can we make it more convenient, really? Because developers are essentially lazy people. So we did what every good developer does when we face a problem that we want to automate. We created a framework for that, which is what this talk is actually about. So this framework that we use for pretty much all our logging needs in basically every project I'm working on and my colleagues are working in, has a different number of features, obviously. One of the main features is that we wrote it in Java and in Bean Shell, meaning we have it as a Java library and a rule library. They do pretty much exactly the same thing. They behave pretty much except just like the others, so there's no difference, but they have very slightly different capabilities, meaning mostly when it comes to using it in Bean Shell. So using it in Java is very straightforward, but using it in Bean Shell has some restrictions or things that it does differently to Java, meaning, for example, when you have something like when you want to display all the variables that are available in your namespace, you can do something like this .variables in Bean Shell, but that doesn't probably work with a Java library because you can't just parse the object type in that instance in a Java library, but you can do that with a rule library. But what that means, I'll come to in a second. So our library includes methods to automatically create log statements in different points in your code. We have methods that create start and end statements. Both of these methods have in common that they take in just a variable number of parameters, which are typically the input variables of a method or the Bean Shell namespace that is available, something like that. But you can put in there really anything you want to that is important for the block of code you want to trace. We have methods that allow you to print out just progress messages, really, somewhere in between your code, like at important steps inside your code. They also take a variable as a parameter so that you can print it out if you want to. We have statements that create log messages for warning and error levels. And we have statements that force a log message on a certain log level, which can be useful in certain instances, more for development than for production use, but they do its purpose. So what these messages do is they set the log level to a certain level, debug or trace in this instance. They log the message on that level and then reset to the log level to what it has been before. So we support different log levels with this framework, which are the usual suspects: error, warning, info, debug, and trace. We didn't include fatal because error typically is sufficient for what we do. And probably the most important or main feature and main selling point, if you want to call it that, of this framework is log level dependent output. So what does it mean? I want to explain that as a little example of our log method entry function. Generally, every method that we have, except the warn and error messages, has different outputs depending on which log level is actually activated. So when we have the log method entry, which looks something like this, with first you pass in the logger that you want to log on, and then you have a bunch of variables that you want to show. If you have warn or error activated as a log level, this method does not produce any output whatsoever. And it is actually created in a way that follows the best practices shown yesterday. So obviously it first checks which log level is activated and then creates the appropriate statement. On the info level, it only shows simple start and exiting messages. So just one word, basically, that is printed into the log, like entering and exiting. On debug level, this method basically prints all the variables you passed in as strings, conjoined with the classes of the object. So you get something like string a, int 1, and so on and so forth, whatever the variables are. The difference to the trace level is that on trace, this method also calls the toXML method on basically all objects that support this method. As we've learned yesterday, this method is it's quite expensive to do. So you only want to do that when you're sure about it, which you should be when you activate a trace logger. And most importantly, it can actually change the flow of your program. I think Adam mentioned that yesterday. You can have the case that when you activate the logger and the toXML is called, your program works just fine. And when you deactivate the logger and it is not called, you have an error. So just to be aware of that, it can happen. I haven't seen that myself, but as we heard yesterday, it actually does happen. So this is basically how our framework works pretty much. We have a few things that we are currently working on to improve that, because currently you still have to call these methods by yourself during development. You have to include them in your code manually, which still is a bit so-and-so. It's better than before, but it's not really convenient. So our plan is to expand that and use the, during our build process, we want to use Java aspects to pretty much insert default log statements at the beginning and end of every method into our custom Java code. That works in a way that the code is compiled, the statements are inserted, and then it's recompiled with those statements. It's just how aspects work, so that we actually don't have to write all these methods by ourselves, but just compile our code and they are automatically inserted, which is pretty cool, I think. And yeah, with that being said, I think it's time for a little presentation or a little demo by Christopher. So thank you for your attention until now. I hope I could give you a little impression of what we did. And yeah, that's it. Thank you.
Okay, thank you, Alex. So after Alex introduced you into our logging framework, we will now take a look at it in a live demonstration. First, I will quickly show you the setup of this demonstration. So we have an IdentityIQ running in version 8.3, and I enlarged everything a little bit so it's easier to read. Additionally, we were using the log4j admin page to set the log levels. And I have a PowerShell running, which is connected to my Tomcat within a Docker container to show you the logs. Okay, so this is the setup we are using. And we are using this with a Wall-Meddler workflow. I will quickly show you the code of it. And keep in mind the sole purpose of this workflow is to show you the logging framework. So don't look too much at semantics of this code. It's just there to show you what the logging framework is providing. So it's pretty much a normal workflow. What you need to do is you have to reference the wool here, the wool library, as you would reference any other wool library. And then you're pretty much good to go. So everything you need to do is, and it's pretty easy, you just have to initialize a logger. And what we are doing is we're defining loggers for every step. So that enables us to individually set log levels for every step within a workflow, which is kind of convenient. And we will use this later on in this demonstration. And all we need to do then is we are calling the log method entry at the beginning of each step. And as a parameter, we're just providing the logger and this.variables, as Alexander already told you about. This is just holding the bean shell namespace with all the variables and their values. And at the end of each code block, we're using log method exit. And again, giving the logger and this.variables. And in this case, I'm providing null. This is the return value. So if this step would do something like return bundle, you could just provide the bundle here. And again, this all provides or gives you log level dependent output. So at the end, we have a few steps here. They are all named step 1, step 2, step 3, and so on. And this is the workflow we will be using now. So we will head back to our IIQ and open the wall modeler. And as you can see, it's pretty empty. And now we will just create a wall. It's not too important what we're entering here. We just want to trigger the workflow. So I will just write br test and just save the business role. And now I will hit submit. And then now we get an error message. So this is not telling us much. It's just telling you an unexpected error occurred. Workflow computed with errors. Let's have a look at the log now. And keep in mind, we're not using the logging framework now because log level is set to 1 currently. So there is no output from our logging framework. So as you can see, there's just normal output here. You have this unable to save object with ID new, which is pretty normal. And if you scroll a little higher, you will see this Java lang null pointer exception, null pointer and method invocation. It's pretty much just this whole null pointer exception, which we all know. And there you have it like script at line null column no. So it's not giving you much information. You only know it's a null pointer somewhere. So we now need to debug this and locate the error. To do this, we will be using our logging framework. So we head over to the log4j admin page, and what we're doing now, we are setting the log level to info. And as you can see, I'm setting it on the top level of the whole workflow, because currently I don't know in which step the error occurs, so I need to set everything to info. Now we just head back to our role modeler and hit submit again. Obviously, we will get the same error. And now we can head back to our log. And now we expect that we get some info logs providing us or telling us in which step the error occurs. So we have to scroll above all this output here. And there we have the output of our logging framework. So what it's doing, as Alexander told you, just telling you it's entering step 1, it's exiting step 1. Same goes for step 2 and step 3. And for step 4, you get also the entering call, but there's no exiting because the exception occurs. So this tells you your error is located within the code of step 4. And in some cases, this is enough because maybe there's not much code within step 4, so you can easily spot the error, fix it, and you're done. But for the purpose of the presentation, let's just say we're not able to do this, so we need more information. And to get more information, all we need to do is adjust the log level again. So we're not adding any new logs, we're not changing any code, we're just heading to our log4j admin page and setting the log level to debug. And now we're just setting it for step 4. This is convenient because we're using different logger for each step, because I don't want to see the debug output of all the other steps, because our error is located within this step here. So let's head back again to this page and hit submit again. So now we expect to get more detailed output. Now we expect to also see the variables and their corresponding values. We have to scroll up again. And finally, there we are. So for steps 1 till 3, you get the same output as before. You get entering, exiting, and so on. For step 4, you also get the entering call, but then additionally, you get this debug log message, which is pretty much printing you the bean shell namespace. So you can see all the variable names, all the parameters, and all their values, which is pretty convenient. And as we are looking for a null pointer, we could focus on everything which is set to null, for example. But again, let's say that's still not enough. We are not able to locate our error. We need to get more information. Because currently, for the bundle, you just get the information ID is null because it's not yet created, and the name is BR_test. And we need more detailed information. So what we can do then, again, as before, we'll just head back to our log4j admin page and set the log level to trace. And obviously execute this again to produce a log. And now we're heading back to the log. And now we expect to get really detailed information. We will expect to get the 2 XML representations of our variables, as Alexander told you. So we're scrolling up again. And as you can see, there's a lot more output now. I have to go to the start of it. So here we are. So again, same for the steps here, get entering, exiting logs. And now for step 4, we get trace logs. And as you can see, for example, with the bundle, you can get the whole content of the bundle, which is really convenient. Because maybe something within the bundle is set to null and causing you null pointer, so you get the whole information. And it's not only the bundle, it's pretty much all the objects. As you can see, there's even the whole workflow case is printed here if you need to check something within the workflow case itself. So you really get all the information you could need. And as I said, I just adjusted the log levels. So there was no edit code. It's really easy to use and really convenient. So this is to spot, let's say, exceptions. But maybe you have a logical error or a semantical error. Let's say there's no exception, the workflow is working fine, but at the end, the bundle does not look like you expect it to look like. And in this case, you can also use the logging framework I will quickly show you the log again, because I have prepared some statements here. As you already heard, you can use log method progress to log progress within your code. If it's not sufficient to use entry and exit, you could also use log method progress. And in this case, I just use bundle before update. I'm giving the approval object. And again, this is producing log level dependent output. And then I just did simply modifications like set display name, calling it again. And then I'm just setting it to disable and calling it again. So pretty easy stuff, but just keep in mind, it could be really, really complex. And maybe you just want to see where your modification of the bundle occurs, which you did not want to see. So now we will head back to this. I will reset this to info, and let's just say now I want to have detailed output of step 3. So again, we are heading to our page here, hitting submit again, and obviously we get the same mistake again. And now we expect to get the contents of the bundle in multiple versions during the code execution. So we will just scroll up here. This is the exiting output, but we're not too interested in this. So here we are. So here you get the output bundle. Here you get the output bundle before update. This is the original version of the bundle. Here you can see it. And obviously you could just copy this and paste it to any notepad and use any compare mechanism you want to use. But for now, it's good for us to just look at it here and just spot the difference, because it's pretty easy to spot. So this is the first version of the bundle, and here you can see after first update, the difference is now you have display name set to display name, which is not happening here. And additionally, we can check the difference between this version and the third version. You can see bundle after second update. Now disabled is set to true, and here this is not set to true. So this is pretty much what you can expect from the logging framework. It's just giving you log level depending output, and it's really easy to use. And it's really fun to use. And one additional thing you can do is, I will head back to my code. We're running out of time, but maybe it's enough to quickly show this to you. Let's use the force trace log, for example. I can quickly show it again. So it's just force trace log. I'm providing the logger. I'm saying force log of bundle and giving the approval object again. And then we will just submit one final time. Go to our log. Now it should be. I should have set the log level back to inform all the stuff. Change this again. So let's see if we can finish this in time. Otherwise, you would need to check it out yourself. Okay, I think time is up. Just to keep it short now. If you have any questions, just ask them in the chat or in the thread in the Developer Days forum. And we will also share the code there, so you can use this logging framework by yourself. So we will share the Java class and the Bean Shell library. Thank you very much for your attendance.